Everyone's
I think they already have it.
Wow, factoring.
Oh, yeah.
Oh my god. You can talk about this.
Well, here we go. 9-3. So again, what is due tomorrow? 9-2. Okay, 9-3 is going to be a couple days, and I think William stated it correctly. When is that going to be due?
Wednesday.
On Wednesday. So we'll take a couple days on this one. Will be our plan. This one is. Let me do a review for us. When we talk about factoring, what are factors?
The numbers that make up
The numbers multiplied together to make up another number, right? So an easy one, like if I said factor, or I mean we talk about the factors. So if I said what are the factors of 10, you would say okay, 10 has a couple different factors, right? What are the factors of 10? It could be 5 and 2 or 1 and 10. Those are factors of 10. And then I said, okay, what are the factors of x squared? X times x, right? We'd say, okay, the factors of x squared are x times x. That one's pretty easy, right? Now, if I said, what are the factors, kind of a funny way to write our notes, but if I said, what are the factors of 6x squared, then we would say, it could be 3x and 2x, or 6x and x, 1x and 6x, right? So those are a couple options as well. And then we started talking about, when we went into initially with factoring, if we said factor this, let's say we had 2ab plus a squared, like that. If I said factor this, what do we do? What were the steps in factoring that? Find what they have in common, right? So then we say, okay, pull out the a, and then you'd be left with 2b plus a. And now that's in factored form because I have a times that, right? So I have a times this quantity. And you redistribute that in. A times 2b would be 2ab. A times a is a squared, right? So then we transition into talking about something like this. X squared plus 5x plus 6. And we factored those ones. Now, when it has a coefficient of 1 in front of our squared term, by the way, these are called what kind of trinomials? It's a trinomial called a, starts with a Q. Quadratic. It's a good term to know. We are reverse foiling. When it's got a coefficient of 1, it's really nice for us because we were getting, I think, doing pretty good with this. We just put the parentheses, and then what goes in here really quick? X and x. Because what's x times x? X squared. You don't have to worry about, is it 3x and 2x, or is it 6x and x? It's just x times x. Easy. Then we had to deal with the 5 and the 6 aspect. Remember what we would ask the question. What times what gives us 6? Because that's your outers. And then added together gives you 5x. That's your outers plus your inners. So we said, well, we could go 6 and 1, but 6 plus 1 gives us 7. So therefore we said 3 and 2. If it was plus plus, we went plus plus. And then we would check it, right? We would do the outers, 2x and 3x is 5x. And we got it. Today, we are going to work with factoring trinomials, but with the ax squared, meaning a is not going to be 1. So let's do some examples here. Okay, factor. This is what we call, when the coefficient is not 1, this is what we call a trial, actually, let's do this one, 4x squared plus 15x plus 9. Okay. Now, first thing to look for is, do they have anything in common? And I kind of skip that part usually because I know they don't have anything in common because I'm teaching, I'm giving specific examples. But we should always look, do they have something in common? Because if they do, it can make our life easier, make numbers smaller. Nothing in common, that'll help us out there. So then we look, okay, this is a trinomial. It's in a quadratic format, x squared, and then an x, and then no x's. We know it's then going to be a parentheses and a parentheses, right? And so when we do this, like this and this, when we had a coefficient of 1, it was very easy to at least get the first setup, right? We just went x times x, we were done. Then, like I just stated, we could just ask, oh, what times what gives you 6? I didn't be able to give you 5. Because the reason for that is this was a 1 on the x, this is a 1 on the x. Meaning, 1 times 2 is 2, 1 times 3 is 3. It doesn't change. The 2 and the 3 don't change. And so you can work with them like individually and say, I'm just going to worry that this is 2 and 3. I don't have to worry that 1x times 2 is going to change it to like a 3. Change it to like a 4 or an 8 or something, a 10. It's just always 1 times 2 is 2, 1 times 3 is 3. Here the issue is, if I said, okay, I'm not going to worry about this, what times what gives me 9 added together gives me 15? Nothing. Now, if that was the case, we might write prime, because we couldn't find out any factors for it. The issue, though, is that this is no longer a coefficient of 1. So now this is going to play into something could be multiplied to this to make it a larger number to get us to there. So this is what I call our trial and error method. What do I mean by that? Well, what I mean is this. What times what gives me 4x squared? Well, I have a couple options, don't I? It could either be 2x and 2x, okay? So we start with that. That is true. When we go to redistribute it or refoil it, what's 2x times 2x? 4x squared. So that's correct so far, right? So now I say, well, what times what gives me 9? 3 and 3, okay. So 3 and 3. So we think about that. We say, okay, 3 times 3 gives me 9. True or false? True. So far, I've checked here and I've checked here. We're good. What's the only thing we haven't checked? It's our 15x, right? So it's our outwards plus our innards giving me this middle term. Now, if this is plus and this is plus, what do we know? This has to be plus and plus. So we check our outwards and our innards, right? We go, okay, 6x plus 6x gives me 12x, right? Our outwards and our innards. So 6x plus 6x gives me 12x. What am I looking for? 15x. So did I do it correctly? No. Doesn't mean it's prime. No, because this could have been 9 and 1. This could have been 4 and 1, right? We have other options. So we tried this, did not work. So let's try something different. 4, okay? So we say 4x times x. Double check that. Is that correct? What's 4x times x? 4x squared. Are we good so far? Yeah. What about then we go to the 9, because that's going to determine the last term. What times what gives us 9? 3 and 3. Okay. So if we go 3 and 3, okay, that also gives us 9. We know it's plus plus, right? We know plus plus. So now we check it. Outwards, what do we get? 12x, right? And then what's our innards? 3x. So what do I end up with?
50x.
Is that what I wanted?
Yes.
There you go. So did I get the correct factors? Yeah, you bet. Now there's other methods that you can do. There's some other formula type methods. I have found those for me and in teaching some of them sometimes. I found it to be a little cumbersome and confusing. I personally just end up going with the trial and error method. There's certain parts of the trial and error method with some logical reasoning. I gotta be careful saying that because you may try it and then feel bad that it wasn't logical. What do I mean by that? That you can kind of hone in. This was a very valid guess. We got 12x out. Is that pretty close to 15x? Yeah, you bet. That wasn't like so far off. When I say logical reasoning, as you get to practicing, I would probably, like, I'll write this, you don't need to write it, but I would say, okay, let me try 4x and x. It wouldn't make any sense to me, because I know outwards and innards, to go 9 and 1. The reason is 9 gives me, and 4 give me 36. Is 36 anywhere near 15? Excuse me, no. So there's some of them that I can quickly kind of mentally eliminate. I'm not even going to try it. Or I place it, no, I'm not going to try it. You may have to try 4 or 5, potentially on some of them. So it takes a little bit of work. And in that case, you know, it may take a little bit of work for these. But after you practice and as you try them, you start to get a little better rhythm of what you're aiming to do. Let's try this one, 6b squared minus 11b minus 10. So again, what I recommend is at least starting, don't, just put some numbers, even if they are not logical in the end, you're like, oh, that was way off. That's okay. You've at least started the process, okay? So with this, what's a little bit different about this is we have a negative and we have a negative, right? So versus a positive, With the positive and a positive, it's very easy. Positive, positive, always. When you get to negative and a negative here, this tells you, this one right here tells us that we have, what times what gives us a negative? Well, it's got to be a negative times a positive. So we're just going to, let's just go negative times a positive. We know that's going to be the case. Okay? Now, don't worry about which one needs to be negative, which one needs to be positive. Just put the negative and the positive right there. All right, so when I say logical guesses, I know mentally before I even try this, if I'm going to write it, it's going to be wrong. I'm going to try to show you, hey, like, yeah, that doesn't make sense. If I go 6 here, 6b, and I go 10 here, meaning 6b times 1b gives me 6b squared, 10 times 1, right? If I do that, I logically thought through that, or mathematically maybe the right saying, and I said 60 and 1 doesn't get me anywhere near 11. So I already knew I'm not even going to try that one, because 60 and 1 don't get me near that. Now, if you did, it's not wrong to do it. Just start with something. Great. Well, that one was wrong, because outer 60 minus 1 gives me not negative 11. Okay, so let's try something else. Throw out a 2b. Okay, I heard 2b. You might have said 2b, and then what does this have to be? 3b. Okay, 2b times 3b is 6b squared. Am I good so far?
Yes.
Yeah. All right. So now you can mentally think through. If I put a 5 here and multiply this, that's great. If it's hard to mentally think through, just plug in 2 numbers and then try it and then go forward. 2 numbers got to be connected to the 10, meaning don't put 7 and 3. Well, that'd be, right? 7 and 3, yes, 7 plus 3 gives you 10, but we're talking what times what gives you 10. So you only have a couple options, 2 and 5 or 1 and 10. So what do you want to try?
2 and 5.
2 and 5, great. 2 and 5. And I already stated, don't worry about the plus minus. We can get there later. All right? Let's do a quick check. 6b squared. When I point to these, I'm saying multiplication, right? Negative 10. Are we good so far? Yeah. Outwards. 10 minus 6, right? Does 10 minus 6 get us to there? Nope. Cross that off. All right, what's another option?
4, 2, no. Can we still do 3?
You can still do 2b and 3b.
Yeah.
You bet. Would it matter if I went minus 5 plus 2?
Not yet.
Sure, because here, right, I had 2 times 5 is 10, but now I'm going 5 times 3 is what? 15, right? So it does matter because I'm going to be multiplying the 5 and the 3 versus the 5 and the 2. I'm getting completely different numbers, so that does matter. So now we check what's 6b squared, negative 10, right? And then what's your outwards? 4b, I'll write it, 4b minus what? 15b, what do we end up with? Negative 11b. What was I looking for? Done. Okay, now you say, well, wait a second, how did I know it was minus plus, plus minus? Maybe you're asking that, maybe you're not. Let's check and say, well, I just said just put minus plus, just put minus plus. What if you had said, okay, 2b plus 5 and 3b minus 2? Okay, what if you had changed those signs? Because I said put minus plus, and then we happened to nail it on our third try. But let's check this out. 6b squared, check, right? Negative 10, right? 5 into negative 2 is negative 10, so we're good. Our outers and innards, this would be a negative 4 plus 15b. I'm sorry, negative 4b. It was a negative 4b. What's negative 4b plus 15b? Positive 11b. What are we looking for? Negative. So if you end up with the correct value, just the wrong sign, just switch your signs. You don't have to switch the numbers, just switch the signs real quick. That's why picking the sign isn't that important in terms of is it negative positive, is it positive negative. Just pick one, and if you ended up with 11b, but you knew you needed a negative, perfect, I got all the right numbers. I just go like this and just go like that, and then you're set. Just change the sign on that. So don't get hung up on the signage initially. Okay. So let's just do. We're gonna go over more examples tomorrow. Okay. So let's do. Did I give you a homework assignment sheet for this?
No.
Nice. I'm so proud of you. Let's do one more and then send you guys the task on your homework. Let's do this one in case some of you get inspired. Or some of you will be gone tomorrow for a variety of unknown reasons. So this way you can at least say, oh, okay, I've seen something kind of like that. Okay. So now what makes this look a little bit more confusing?
There's two variables.
Two variables. But as we've seen, although a little while back, a week plus ago, the double variable doesn't mess things up. It's actually very straightforward. Check, is there anything in common? I didn't ask that on number 2, but is there anything in common? No. No y here, no x here, odd, so therefore there's no, and these are both even, nothing in common, okay? So we look and we say, okay, let's go like this, let's go like this, go like this. It's a negative, so what do we know our signage needs to be? Negative, positive, or positive, negative, it doesn't matter. I just put negative, positive. Okay? Now, let's think about 6x squared. 2 and 3, okay? 2x and 3x, not a bad route to go. Now with the 20y squared, 5, you want to do 5 and 4? Okay? So when we do this, what's the only issue that I have to deal with the variable? Just tack a y on there and tack a y on there, and then you're set. Okay, it's a little bit more cumbersome just because of the notation, right? And you're seeing the y's in there and the x's, a lot of variables going on, but the numbers, the steps are still the same. So we check it. Ready? 6x squared, check. Negative 20y squared, check. Now all we have to do is check our outwards and our innards. So we go 8, right? 2 and 4 is 8, minus 15. 8 minus 15. And yes, it is 8xy minus 15xy. So we do have the xy's connected in there. What's 8 minus 15? Negative 7. We can quickly know that 8 minus 15 is not going to get us to negative 19, right? So you don't even have to bother doing the math out. You just know that 8 minus 15 does not get you to negative 19. So is that correct? No, if you flip the signs here, and you say, okay, I'm just going to go 2x plus 5y, and then 3x minus 4y. If you change the signs, I kept the numbers the same. I just changed it positive, negative. I'm just going to end up with a negative 8 plus 15 and a positive 7. That's all that's going to happen.
I'll say like change the 5 to y.
Okay, so keep your, William's saying this, 2x minus and then 3x plus. He's saying take the 5y, bring it over here, and then take the 4y and bring it over here, right? That's going to change it because now I'm going 2 and 5 is 10, right? And then 4 and 3 is 12, so I'm getting different numbers. But a 10 and a 12, does a 10 and a 12 get me to a 19? No, so not going to work there. Abby?
Oh, what if you kept the 5 and 4, but did 6 and 1 instead of 2?
6x plus 5y, and then 1x minus,
Yeah.
what are we doing?
4y.
4y. Okay, so we get negative 24 plus 5. What's negative 24 plus 5? Negative 19. Is that what I'm looking for?
Yeah.
Yep, so did we nail it? Yep, making sure that you have x and x, y and y. Okay? So tomorrow I'm going to give more examples and maybe show you like an algorithm, like kind of a formula process to plug into. But the formula process, like I said, is not easy. It's not like, oh, plug in here, 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 and you're done. It's like, it's a multi-step thing. That's basically what we're doing here is we're guessing and checking, guessing and checking. So that's all there is to it. But the checking part's really important to understand the foiling, outers and inners to get you there. So what is due tomorrow? 9-2 and 9-1 for some of you. And then what is, this will be, we're going to teach a little bit more on this tomorrow. When will this be due? Wednesday. And then we have an MCA coming up. Now, what numbers do you guys need to do? Because I didn't give you the numbers. Yeah, all. No, not all. We're going to page 433, numbers 1 through 33 all.
Oh my goodness.
No. 1 through 31 odd. Yes, let's throw a little cumulative review on there. You know how it is. You know I like to do that every once in a while. Just a 42 and a gentle ABC 47. There you go, tack on those two.
I need this one on a piece of paper, please.
Okay, so 1 through 31 odd, then tack on 42 and 47. I'll get you. Oh, for 9-1, 9-2. Oh, wow.
Hey, dude.
Wow.
Hi, Ed.
That was close.
Mr. Olsen, have you ever